At a time when climate change, the finiteness of fossil fuels and the risks posed by nuclear energy are clear to everyone, a global energy revolution has become inevitable. Within just a few decades, we must be able to produce vast quantities of electricity, heat and cold entirely from renewable energy sources. The Fraunhofer Institute for Solar Energy Systems is the largest solar research institute in Europe. Founded in Freiburg in 1981, it has contributed significantly in facilitating the explosive growth of the solar industry. Here, over 1,000 employees develop new solutions and technical innovations for the generation and storage of solar power and heat. Through the development of optimized concepts for an intelligent grid management and successful research in the field of energy efficiency, the scientists open up new perspectives for a sustainable global energy concept. Through its industry-driven research, Fraunhofer ISE supports commercial enterprises in developing and launching new technologies. Fraunhofer ISE also has links with other research institutes worldwide, including a shared facility with MIT in Boston. With over 250 diploma and PhD students, the institute serves as an important center for training the next generation of scientists.
Solar energy is without any doubt the renewable energy source with the biggest potential. And since more than 30 years, Fraunhofer ISE has been working hard to make this potential available for humankind. In addition, in the last decade, Germany achieved a technology leadership position, and we would like to help to make this position stable in the years to come. Our goal is to provide economic and effective energy supply by reducing the costs of photovoltaics and increasing its efficiency, by providing solar heat supply, and a whole range of further ways to provide renewable energy.
Around 80% of photovoltaic cells sold today are based on silicon. Already at the beginning of the value chain, during the melting of the raw silicon and the subsequent recrystallization, researchers have been able to produce silicon blocks with especially high purity. Even with metallurgical grade silicon, which costs only a fraction of the high purity silicon, high-grade materials suitable for efficient solar cells have been successfully produced. Thanks to new sewing techniques, it is possible to cut increasingly thin wafers and use them for new cell technologies. New concepts for silicon solar cells are being researched at PVtech in a pilot line for the production of solar cells. This has enabled the metal wrap-through, or MWT solar cells, with an efficiency of over 20% to be manufactured entirely in industrial-scale processes. In the development of MWT cells, new procedures in wet chemical processing and surface passivation play a fundamental role. The key idea? Cells designed to transfer some of the metal contacts from the front to the rear. This was achieved using lasers to bore holes, which are then filled with a metal-containing paste by a screen printing process. As a result, less of the photoactive front surface is covered, and cell efficiency is increased significantly. Innovative laser technology will become more and more important for future generations of solar cells. As, for example, in creating rear surface contacts by laser firing, which is a key production step in the industrial-scale processing of solar cells. Dramatic increases in solar cell production are making the efficient use of raw materials increasingly important. A metallization process developed at ISE should one day allow expensive silver contacts to be replaced with cheaper copper contacts. Fraunhofer researchers have been extremely successful at creating innovations for every stage of the value-added chain. They were also the first to produce multicrystalline silicon solar cells with efficiencies of over 20%, thanks to a completely new surface texture which captures light more effectively. In the PECVD lab, ISE's scientists work with incredibly thin coatings. In this system, aluminum oxide is deposited on wafers, whereby singular atomic layers can be selectively applied. Such research will lead to the development of novel types of solar cells. In addition to optimizing solar cells, improving module technology also has a significant impact on the efficiency of a photovoltaic system. Using innovative soldering methods shown in this industrial scale system, as well as alternative connecting technologies and new module concepts, the researchers in Freiburg are able to provide increasingly cheap and efficient PV systems for industrial production. With the test lab PV modules and the calibration laboratories, Fraunhofer ISE offers a complete range of testing and quality assurance services for photovoltaic manufacturers. Here, photovoltaic components and modules can undergo comprehensive tests and certification procedures. In addition to silicon solar cells, research on a wide range of alternative photovoltaic technologies is carried out at Fraunhofer ISE. For example, dye solar cells, where a dye converts light into electricity. This type of solar cell is ideal for integration into building facades. With organic solar cells, new possibilities are accessed in the area of portable electronics. And thanks to the highly efficient 3-5 concentrator solar cells developed in Freiburg, which have been repeatedly acclaimed in public, large solar plants exist today which harvest enormous quantities of solar power. Research in this young technology is continuously being carried out under full steam at Fraunhofer ISE in order to increase electricity yields even further. An ISE spin-off company working on this technology has been successfully launched and has a staff of over 100. In the solar thermal technology, the Freiburg researchers are also exploring new paths, which aim to exploit new potential for recovering solar heat. Bionic principles are applied in this absorber to improve heat recovery and reduce pressure drops. One particular area of application for this absorber type is the facade integration, where the collector generates both electricity and heat. In this measurement lab, the researchers identified the optimum mirror geometries and materials. New mirror types for collectors are developed to further increase the efficiency of solar thermal power plants.
Many of the renewable energies are generated in a timely, fluctuating way, and therefore we need storage technologies to make sure that we have a 100% renewable energy supply. Here at Fraunhofer ISE, we work at new, innovative and cost-effective storage solutions for electricity, for heat and for cooling applications.
In order that large solar thermal power plants generate electricity through the night, new devices are being developed at Fraunhofer ISE that enable solar heat to be stored with as little loss as possible. In this molten salt plant, energy is stored in a brine and then released as the brine crystallizes. Thus, some of the solar energy harvested during the day can be used at night to generate electrical energy. The hydrogen technology offers the possibility to store renewable energies on a large scale. Fuel cell researchers are working intensively on converting hydrogen into electricity and heat with minimum losses. They develop small modules for portable and off-grid applications and optimize this cutting-edge technology for a wide power range and all climate zones. Big advances have also been made in generating hydrogen. With new electrolyzers, energy use has been successfully reduced. As the only type of renewable energy that can be stored in its original form, biomass can balance out the fluctuating energy supply of solar and wind. Based on the example of wood gasification, research is being conducted into how to produce tar-free gas that can be burnt directly in cogeneration plants. Energy can even be stored in buildings. At Fraunhofer ISE, phase change materials are developed and incorporated into plaster and plasterboard in the form of small microcapsules filled with paraffin wax. Their material properties enable them to attain the same thermal storage capacity as a massive wall. Since renewable power generation has a high volatility, technologies for electricity storage are becoming all the more important. Together with cooperative partners, the Freiburg researchers are working on new storage solutions, such as this durable lithium-ion battery with an efficiency of 95%. This battery is also suitable for use in private homes. In redox flow batteries, energy is accumulated chemically in electrolytes and then stored in external tanks. This battery technology opens up entirely new perspectives.
Buildings account for more than 40% of our energy use, and therefore it is essential that we improve the energy efficiency of buildings. At Fraunhofer ISE we work at innovative concepts to decrease the energy use, to increase insulation, to make buildings low energy buildings or even plus energy buildings which create more energy than they need.
At the heat pump test stand, researchers investigate technological components and control systems for the building services. They also develop new, efficient heat pump systems for integration into solar energy concepts. But buildings themselves also need to become more energy efficient, particularly older buildings. Fraunhofer ISE accompanied the renovation of this building. It is the world's first high-rise block to meet passive house specifications. The multifunctional facades of the future will also be energy generators. Concepts for integrating solar modules into the building envelope represent a research field showing great potential. Houses of the future will require more than just heat and electricity. In Freiburg, new paths are being pursued in air conditioning technology. In this solar cooling plant, cold is generated using sorption technology. The energy needed for this process is supplied by a solar thermal system.
In addition, we need to develop a smart energy grid, which makes use of energy when it's abundantly available and which integrates transportation. In the form of electric mobility, we find ways to integrate car batteries as energy storage solutions to provide a stable overall grid.
In the Smart Energy Lab, Fraunhofer researchers develop new ideas for building energy systems of the future. These aim to coordinate the energy generating systems, the energy storage, and the consumer perfectly to each other. Smart power meters ensure optimized energy management. Cleverly devised power electronics for inverters minimize losses occurring when electricity is converted from direct to alternating current. Achieving a top efficiency of 99.03%, the Freiburg researchers set a world record for photovoltaic inverters. Since 2010, Fraunhofer ISE operates a megawatt laboratory where even inverters for large-scale PV plants can be investigated. So-called smart grids are also analyzed and further developed in the Smart Energy Lab. Here, comprehensive simulation modules allow the grid specialists to investigate complex questions. In the future, there are no more needs to fulfill than just the provision of electricity, heat, and cold. Therefore, at Fraunhofer ISE, researchers are also focusing on electric mobility. They develop technical solutions for battery-powered electric, plug-in hybrid, and hydrogen-powered fuel cell vehicles. And often the ideas which result can be truly surprising.
With all this work, we strive to help solve the biggest problem of humankind at the moment, which I think is a climate problem, and simultaneously help in the transition away from the use of finite fossil energy sources towards the use of 100% renewable energy. With this broad interdisciplinary research approach, Fraunhofer ISE is ideally suited to make a significant contribution to this transformation.